Good morning, this is Ms. Billerbeck, and we're going to talk about 2.5, solving problems using simultaneous equations. So we read the statement, the sum of the digits in a two-digit number is 13. So let's say we have a two-digit number x, y. So it's 13. So we have our first equation, x plus y equals 13. And then it goes on and it says, if the digits are reversed and the number formed is 45 less than the original number, find the original number. Okay, so if we have x here, the x is in the 10 spot. So if we wanted to make this number is 10x plus y. Because let's say that was 53. So x would be 5. 5 times 10 would be 50. Y is 3, so 50 plus 3 would be 53. If we had y and x, that would be 10y plus x. So that's what the number looks like reversed. Kind of interesting. So we could say the reverse number, 10y plus x, if we add 45 to that, it should equal 10x plus y. Okay, so we have two equations now, and that's what we need if we have two variables. So to solve for two variables, we need two equations. All right. There we go. So first we want to take this equation here, x plus y equals 13, and solve for one of the variables. So we can do substitution. So we are going to take the y and put it over here. So we have x equals 13 minus y. Then we're going to look at this equation here, 10y plus x plus 45 equals 10x plus y. So I'm going to substitute this in for x. So I have 10y plus 13 minus y plus 45 equals 10, and I'm going to substitute this again in for x. 10 times 13 minus y plus y. Okay, so I don't really need these parentheses here. I just put them in there so you knew that that was x. Okay, so at this point I can start putting things together. There's really a 1 right here in front of this y. So 10 minus 1y is 9y. And 13 plus 45 is 58. Okay, then I'm going to distribute this to those. So I have 10 times 13 is 130. 10 times y is minus 10y. And then I have plus y. So this simplifies. So we're going to do a simplify step here. So we have 9y plus 58 equals 130. And then this is negative 10 plus 1y. So that's minus 9y. Okay, so we're getting there. It's a long problem. All right, so I'm going to start moving things around. I'm going to add this 9y to the other side using an additive inverse. And I have 58 equals 130, and that's 18y right here, and that's 0. So now I'm going to use an additive inverse with the 58. So this gives me 18y plus 0 equals, and this one is going to be, if I borrow one from here, I've got 72. So when I divide by 18 and use a multiplicative inverse in the SAM process, I'm going to divide by 18 on both sides. I end up getting y equals 4. Now that I have y equals 4, I can go back and substitute it in here and say 13 minus 4 equals 9. So it said find the original number. So if x is 9 and y is 4, the original number is 94. And we can check that, 94 minus 45. So if we subtract 45, we get 49. So it works out perfectly. And there you have it for that problem. Okay, so that was quite a long problem, don't you say? Okay. Let's try the next one. So the next one, we have a shirt and a skirt, and they cost a total of $138. So I'm going to call H the shirt, and I'm going to call K the skirt. Okay, so I have H plus K equals $138. And then it says 3 skirts. So H is my skirt. So 3H plus 2 skirts, K is skirt, plus 2H equals 331. All right, so this one I can again do substitution. So if I subtract a K from both sides, I get H equals 138 minus K. So I did that by subtracting a K from both of those sides. Okay, now I'm going to substitute into that. And this should be a K. So I have 3 times 138 minus K plus 2K equals 331. Okay, so 3 times 138 is 24, 11, 4, 14, minus 3K plus 2K equals 331. These problems are much too long. So now we're going to continue on with this lovely problem. So we have 3K minus 2K is negative K, and we have 414 equals 331. So I think I'm going to just move K over here just to make it easy. So I have 414 equals K plus 331, and subtract the 331 using an additive inverse. And I get K equals, and this is 3, carry that, I get 8. So I have K is $83. So that means my skirt is $83. So I can go back to the original equation, H plus K equals 138. And I have H, and I subtracted that. So that's minus K. So I have H equals 138 minus K, which is 138 minus 83. So that gives me H. And so if we want to do it the easy way, this is the easy way to do it. And we have $55 when we subtract. Okay, so we have the skirt is $83. And this is our shirt, $55. All right, so one more, whoops, didn't get all that, did you? Okay, so there you go. These problems are way too long. So, all right, so that is this problem. So we subtract and we have all that. Okay, so the next problem. Okay, so we have two cars and they're going in the opposite directions. And they meet in 4 minutes. Okay, so they're going the same direction. Car A overtakes car B in 20 minutes. So find the speed of each car in kilometers per hour. So if we're going to do this, we need to understand rate times time equals distance. So kilometers an hour times hours equals kilometers. Okay, so the speed is the rate and the time is 4 minutes, but they want it in hours, so we need to convert. Okay, so let's do that. Let's actually do this. We've got one chart here. Okay, so one of the charts, the two cars are going, and they're 8 kilometers apart. Okay, one's going to go a little bit less than the other. Let's see, car A appears to be going faster because it's overtaking car B. So let's make it like that and like that. So this is car B, and this is car A. All right, so we need to convert 4 minutes to hours. So 4 minutes, and there are 60 minutes in an hour. So now we're going to get everything in terms of hours. So this gives us 1/15 is our conversion for minutes. So this is 1/15 of an hour. Okay, so that means that if A is going 1/15 A and 1/15 B. So 1/15 A plus 1/15 B is going to equal 8 kilometers because we did rate times the time is 1/15 of an hour equals 8 kilometers. So next what we're going to do is we are going to look at how we're going to get the second equation. Okay, so the second equation, we have the two cars, A, and we have car B. So we have A and we have car B, and they're still 8 kilometers apart, but they overtake each other here. So that means that car A is zooming here and car B is zooming there. So if we have the equations for these two, we know it's in 20 minutes. So the conversion is 20 minutes over 60 minutes is 1/3 an hour. Okay, so 1/3 an hour gives us, we have 1/3 times the rate B and 1/3 times the rate A. So if we subtract these two rates, we are going to get 8 kilometers. So our second equation is going to be 1/3 A minus 1/3 B is going to equal 8 kilometers. Okay, so there we have it. So now we need to figure out how to substitute or how to do elimination. So I could divide everything. No, how am I going to do that? Again, they aren't very kind in this book, but all right, so I'm going to multiply everything by 3. And I've got 3 times 1/3 gives me A. 3 times 1/3 B is B. And 3 times 8 is 24. Okay, for this one, I don't want to deal with the fractions. 15, everything's multiplied by 15. Okay, so I'm multiplying this one all by 15. So I have A plus B, and then 15 times 8 is 8 times 5 is 40, carry a 4, 8 times 1 is 8, plus 4 is 120. Okay, now I'm going to put the two equations together. And I'm going to add them and use elimination. So that gives me 2A plus 0 equals, and then this is 144. So I'm going to divide by 2, and that gives me A equals 72. So A is going 72 miles an hour. Okay, so we can choose either one of these equations. These are nicely done, so it's easy to find B. So we don't want to do anything that's hard. Okay, so let's use this one. So this one, A is 72 plus B equals 120. So we subtract 72 and we get B equals, and we're going to take one from here, that's 8:48. Okay, so now we know how fast these cars are going. Okay, so the moral of the story is car A is going 72 miles an hour. So we can come back here and say 72 miles per hour. And car B, I'm sorry, not miles per hour. We're dealing with kilometers. I'm being too American. Kilometers per hour. Okay, and then B is 48. So we have 48 kilometers per hour. And that's how we solved it. Okay, sometimes it's not easy, but we can do it. All right, so there you have it. Some real life issues that you can solve using either substitution or elimination. Have a wonderful day. Bye-bye.